Okay, so as we were talking concerning dimensions and units, we can deal with different types of systems. We'll see how. So any physical quantities can be expressed function of each other, and you need to define primary quantities and secondary quantities. What do we mean by this? So for example, you know that some basic quantities can be length, time, mass, and temperature as dimensions. So let's say you want to work with these as principal quantities. Okay, if I have a force F, how can I express it? To know how to express the force F, I should go back to the law of which will give me F. By definition, the Newton's second law states that sum of forces equals to ma. So I can say that the unit of the force F can be derived as function of unit of mass and unit of acceleration. Unit of mass is kilogram. Unit of acceleration is meter per second square. So if I'm working in a system with primary physical quantities, length, time, mass, and temperature, we do the following symbol. The dimension of length is L. The dimension of time is T. The dimension of mass is M. And for temperature, sometimes we use the following symbol, theta. So now I can express any new parameters, dimension, function of these. So now if I want to represent the dimension of F, I say it's kilogram, so it's dimension M, times meter per second square, so times dimension L over T square. In this way, I was able, so we say in this case that the primary quantities are length, time, mass, and temperature. And the secondary quantities in this system are any other variables that we can express function of the others. So let's say, for example, in dynamics, you have considering that work is equal to the force times the distance. So if you want to express the dimension of work in this system of units, then you will replace the force F by ml over t square. So its dimension is ml over t square. While since you are multiplying by distance and the distance has a dimension of length, so it's times L. So you end up that the dimension of work is ml square over t square. Now, what if I want to change the primary quantity? So let's say I want to replace mass, for example, by another variable. What can I do? I can do it. Why? Because we have seen together that what is the dimension of F? The dimension of F is ml over t square. Okay. So as you can see here, F is related to all other parameters. In particular, it's related to mass M. So what I can do, I can replace the primary quantity of mass by F. In this case, I obtain a new system, but it will still work. So instead of saying I am working in system length, time, mass, and temperature, I say I will work with the system L, length, time, force, and temperature. In this case, I will express all other variables function of these. So now, if you want to express what is the dimension of mass in LTF theta system, then instead of writing F equals MA and finding the unit of F in the system LTM theta, now you will write M function of F and A. You will say M is F over A. So if you want to write M in LTF theta system, you will say that the unit of force here, because it's a primary quantity, so it's F over, what is acceleration? Acceleration is meter per second square, so F over L over T square. So now in this case, in this system, LTF theta, M is a secondary quantity, while F is a primary quantity. And M can be, the dimension of M can be simply written as F times T square over L. Now, let us take the same example of work. If you want to express work instead of LTM theta system in LTF theta system, it's easier here because work is F times D. So since now F is a primary quantity, all you have to say is that the dimension of work is F times L. Okay, so we will have some problems to practice on these. Any question before we continue? So as we said, we have different system of units. We have the MLTT system, the FLTT system, and also a system that is less used is the FMLTT system, which is called the English Engineering System of Units. In general, we work with these two, but I will introduce for you what is the English Engineering System of Units. Okay, so now to start with, in general, we have two main system of units. We have the SI system and we have the British system. In the SI system is the one that you are more familiar with. It's the International System of Units. In this system, for example, for mass, you consider, of course, the unit is kilogram. For force, the unit is in Newton. For time, it's second. And for temperature, it's Kelvin. Okay. Now, in the case of British gravitational system, you will deal with slug for mass. You will deal with LB for force. You will deal for time. It's the same. It's second. Okay. While for temperature is Fahrenheit units. So in general, we will work with the following system. But you should know also British system because you might encounter some British units. So in summary, I will write here what are the main units. So in this system, you have meter for length, you have a kilogram for mass, and for time we have seconds, and for temperature we have the Kelvin. Now, in the British gravitational system, what is equivalent to kilogram is slug. So when we deal with British gravitational system, the unit of mass is slug. Here, the unit of force in this system is Newton, while in British gravitational system, it is LB. And just you should pay attention so equations all are the same, but mainly you don't have to convert from one system to the other. So if you have a problem with British system of units, keep it in British system of units. Just you should pay attention that, for example, G in SI units is 9.81 meter per second square. While in British gravitational system, it's 32.2. Now, instead of meter, the unit in the British gravitational system is feet. So it's 32.2 feet per second square. Okay. So if I give you, let's say, the weight, I will give it in English system in LB. Okay. If you want to find the mass in slug, in order to calculate the mass in slug, all you have to do is to divide the weight in LB by not 9.81, you should divide it by 32.2, and then you will obtain your mass in British system of units. Okay. Now for the English engineering system of units, it's not used a lot, but what is the idea about it? In general, when we define the SI unit system, we consider that when we write F equals ma, the Newton force was defined in this way. 1 Newton is the force required to be subjected to a mass of 1 kilogram to produce an acceleration of 1 meter per second square. In the same way, for the British gravitational system of units, the convention was the following. When we write F equal ma, we define the unit of force, which is 1 lb. 1 lb is the force needed to be applied on a mass of 1 slug to give it an acceleration of 1 feet per second square. However, in the English engineering system of units, we decided to do it in a different way. In the English engineering system of units, we said that we will define the force of 1 lb is a force that when exerted on a mass m, the mass in the English engineering system of units is in lbm. So if I apply 1 lb on a 1 lbm mass, I will create an acceleration A equals to g, which is 32.2 feet per second. You know,
دكتور أنا على الساعة 12 رح تروح الكهرباء عندي فحضطر سكر.
Yeah, it's not a problem. We'll be done. Yani we are nearly done. Okay.
Deal, doctor.
Okay. So G is 32.2 feet per second square. So it's just a way of definition. Why we did this definition? We did it in a way such that if I give you the weight in lb, it will be equal to the mass in lbm, because starting from this definition, this will lead that the weight in lb is equal to the mass in lbm, because what is w? W is m over g. Okay, and by the way we defined this system of units is that the application of one force on a mass of 1 lbm will lead to an acceleration of equal to the value of g, which is 32 points. Okay. Now, the last aspect that is important also in fluid mechanics is the analysis of the experimental error. So we will see that experiments will also play an important role of understanding the behavior of fluids, because in some situations it's very complex to come up with an analytical solution. So let's say if you have a turbulent flow, how we developed solutions, we did experiments to come up with empirical relations. So engineers performing experiments must measure not just the data, but also the uncertainties in their measurements. So we should understand how to do experiments and how to do the analysis of our data, and we should also repeat these experiments to know what is the degree of uncertainty involved when doing these experiments, to give accurate results that we can rely on to come up with design charts. So for example, one of the main application of this is the Moody chart. So we will work a lot on the Moody chart and see its importance. Okay, so we'll stop for today and we will meet next time. Thank you.